All right, hello students. Hopefully the test went well. So what we're doing today with this video lesson is we're basically just previewing the next unit that we're gonna do, kind of talking about some concepts that you guys are very familiar with from 8th grade. So in particular today, it says 4.1 notes, graphing lines in slope-intercept form, pre-unit notes after exam. So basically, I'm calling them pre-unit notes because these are things today that you should have already learned in middle school, but we're just kind of reviewing them or recalling them so that you will be good to go for this lesson, for this upcoming unit. So the first thing we're going to talk about on this front page here is it says the slope. And so I would like you to pause the video and take 30 seconds or so to read this definition to yourself. So hopefully that, that definition kind of rang some bells. So slope can be thought of a lot of different ways. Rise over run is one way. The change in y over the change in x is one way. The difference over the y's over the difference of the x's, that's another way. So example 1 says find the slope of the line. It says describe the slope of each line, then find the slope. So the first part where they say describe the slope, I would describe this slope as positive. It's sloping upwards. The next thing I would say is you can kind of see the arrows that they've drawn in here. First, they draw this arrow going to the right, and then they draw this one going up. I will tell you that my personal preference is kind of to try to do the rise before I do the run. And the reason for that is just so that we can remember rise over run. So if you do it that way, you would say, okay, how far up do I have to go from this initial point to get to the next point? Well, you would go up 4 and you would go to the right 6. If you then wrote that as rise over run, that would be 4 over 6. But 4 over 6 can simplify to 2/3. So the slope of that particular line is 2/3. All right, the next one, I would describe this as a negative slope. And then to find slope, I should have said this on the last problem, but all you need is you just need 2 points on a line. They can be any 2 points, but it's best to pick ones that you can kind of clearly see where they are. So the textbook has kind of helped you out by already identifying these 2 points. Now I'm going to say to myself, how do I move from this point to the next one? Well, I move down 3 and I move right 2. If I put that in rise over run format, that would be sorry. Let's see if I can get this off my screen. So if I put that in rise over run format, that would be -3 over 2. So the slope of that particular line is -3/2. All right, next one says describe the slope of the line, then find the slope. I would like you to pause the video and see if you can answer these 3 questions. Okay, in terms of describing the slope, that part should be pretty easy. You know, the first one I would say is negative, second one's positive, third one's positive. And you may notice in this video that I'm going kind of quick through it. And the reason for that is, again, this should all be review. If I'm going too fast, just pause the video at any point. So rise over run, it looks like I have to go down 2 and then over about, let's see, 1, 2, 3, 4, 5, over 5. If I put that in rise over run format, the slope of that particular line is -2/5. I can't simplify that anymore, so that's just how I'm going to leave it. All right, the next one, it appears that I need to go up, let's see, about 4 units. And then it looks like I need to go over about 6 units. 4 over 6, which simplifies to 2/3. The slope of that line is 2/3. All right, next one. Looks like I need to go up about, 4 units, and then over 2. So rise over run, 4 over 2, 2 over 1. The slope of this line is 2. Okay, next. The next thing that hopefully you learned how to do in 8th grade was how to find the slope from 2 points or from a table. So this says, how can you find the slope of each line from the table? What is the slope of the line? If you go back up to the slope definition, one of the ways that I circled was y2 minus y1 over x2 minus x1. You've probably seen this formula before, but what a lot of students mix up is they can never remember. Now, is it y1 minus y2, x1 minus x2? Which comes first? Well, the truth is, as long as you put the y's on top and the x's on bottom, it does not matter. Either whether you put y1 or y2 first, it really doesn't matter. You just have to put the y's on top, the x's on bottom, and keep things consistent with how you put them in this formula. So, if we want to find slope from this table, here's how we could do it. We could think of this number of 14 as a second y value. We could think of 20 as the first y value. We could think of 7 as x2. We could think of 4 as x1. We would then simply set this up as 14 minus 20 over 7 minus 4. That is going to simplify to negative 6 over 3, which simplifies to negative 2. The slope of that particular table, or that table that's representing a line, would be negative 2. All right, next one. Now it's getting a little interesting. So, if we do the difference of the y's over the difference of the x's, here's what you're going to notice. 2 minus 2, that is 0. 1 minus a negative 1, the double negative makes this positive, so it's 0 over 2. The slope of that particular line is actually 0. And we're going to see an example of that on the second page of notes here in a second. But the slope of that particular line is 0. All right, next one. All right, so we're going to go 0 minus negative 3 on top, and we're going to go negative 3 minus negative 3 on bottom. I would like you to pause the video and see what you get with this. Okay, so here's what I'm coming up with. Again, the double negative makes a positive. Well, if you do that, what you end up getting is 3 over 0. You might be tempted to say, well, that means the slope is 0. But that is not the case. If 0 occurs in the denominator, that actually creates a mathematical situation where we describe it as being undefined. And the way that I remember this is, let's actually go ahead and flip over your paper. The way that I remember what undefined is, I say to myself, well, it's not a positive slope, it's not a negative slope, it's not 0 slope, or it doesn't have a 0 slope. We can't describe it in any of those ways. Therefore, we're going to just describe it as undefined. It's a vertical line, undefined. Okay, there's a couple things I want you to add to this concept summary box. So not much to add on the positive and negative slope. I think those are pretty straightforward, and I'm sure you're familiar. One thing we do at DeSoto High School sometimes to teach these next two concepts of slope, we use an acronym known as HOI-VUX. And I want you to write out this acronym. So HOI-VUX. And the purpose of this acronym is not to just sound like a funny, word, although it kind of is. The purpose of the acronym is to help you remember characteristics of these two things. here's how it works. The H stands for horizontal. So horizontal lines have 0 slopes. So slopes that are equal to 0, and they are in the form y equals. That means that their equation you'll see it in the form y equals whatever. So for example, this one could be y equals 3 if it went through 3 on the y-axis. Excuse me. Okay, so what is the Vux part of this? Well, the V stands for vertical. So vertical lines have undefined slopes, and they are written in the form x equals, like x equals something, whatever. For example, on this one, this could maybe perhaps be written x equals 4. Excuse me, if this was 1, 2, 3, 4, this blue line right here could be representing the function x equals 4. Okay, so those are our 4 basic types of slope situations that you're going to encounter today. So the next thing is kind of the grand finale. We're kind of putting everything together, and this was actually our major objective for today, which we haven't even gotten to yet, which was to graph lines in slope-intercept form. We're not going to look at very many examples of this because, again, this should be review. I would like you to pause the video and I would like you to read this to yourself right now. Okay, so hopefully you remember slope-intercept form from 8th grade, which is this guy right here, y equals mx plus b. The m is the slope, the b is the y-intercept. This next part says a linear equation written in the form y equals 0x plus b, or y equals b, is a constant function, and the graph of a constant function is a horizontal line. Well, does that relate to something we talked about just a moment ago? Yes, it does. If we have a line that has a 0 slope, that falls under this category right here of Hoy. So we could also say that this is a constant function. Undefined slope problems, you may not describe those as constant functions. That's a different thing. But ones that have a slope of 0, those are constant functions. Okay, 2 more problems here. So example 3, it says find the slope and y-intercept of the graph of each linear equation. Pause the video and see if you can answer these. On part A, the slope is 3. The y-intercept is 4. On this next one, you could rewrite this in the form y equals 0x plus 6.5, which means the slope is 0 and the y-intercept is 6.5. This would be a horizontal line through 1, 2, 3, 4, 5, 6, through 6.5. That's what that line would look like. Okay, and then the last one is not in slope-intercept form, so before we can answer this, we need to convert it to slope-intercept form. You don't want to leave the negative on the y, so you need to divide both sides by a -1. Once you've converted it, you will see that the slope is -5 and the y-intercept is 2. All right, final problem. We're actually gonna graph something. So it says graph 2x plus y equals 2, identify the x-intercept. And let's go ahead and also identify the y-intercept while we're at it. So the first thing you may notice is that this is not in slope-intercept form. So to put it in slope-intercept form, you need to subtract 2x from both sides. Y equals -2x plus 2. One thing that I like to do, I like to make the slope a fraction. Okay, so right now, we should be able to identify the y-intercept. It is very clearly 2 or the coordinate point 0, 2. That's where we're going to start our graph. go to the y-axis, plot a point on 2. That is the y-intercept. Next, we don't know the x-intercept yet, but we're going to graph something and graph the line and see if we can get there. So I want you to think about rise over run. The rise is -2, which means we are going to go down 2. The run is 1. Okay, so I'm going down 2 and I'm going over 1. There's my next point. 2 points is enough to make a line, but sometimes it's best to get 3 points to give yourself a better idea of where the line's actually going. So you can repeat those steps, down 2, over 1, and we have 3 points. From there, we're going to connect them. And we have just made a line, or graphed a line using slope-intercept form. We already identified the y-intercept as being 0, 2. I want you to pause the video and ask yourself, can you identify the x-intercept? The x-intercept should have been 1, 0. Sorry, my pen is having some problems. 1, 0, because that's where the point crosses the x-axis. All right, you have an online assignment today, a brief assignment that covers all of this. Again, none of this should be new, but all of this review is going to prepare you for what we're doing next class.